Hello everyone. My name is Lakshmi and today I am going to present the first milestone of my project for the course Educational Technology CS6460. I have taken up research-based project on tracing methodologies in adaptive learning systems. This presentation will start with the purpose of the project and follows with terminology, research methodology used and the initial findings. Starting with the purpose of the project, it mainly aims at the meta-analysis of learner modeling techniques using various tracing methodologies and produce a final report. Moving on to the project, let's start with terminology used. I have divided terminology as three parts: learner modeling, tracing methods, and dynamic methods applied in knowledge tracing. Starting with the learner modeling, it is subdivided into two parts as context of learner modeling, learner and domain modeling. The given figure represents the basic context of modeling learner's knowledge. A learner interacts with an item. Data about the performance are processed by the model, and then the model outputs are used to influence learner's future interactions with the system. The inner loop is related to a learner's short-term behavior in the process of interacting with a single item. The outer loops are concerned with the tracing a learner's knowledge across multiple items. The next terms are learner and domain modeling. Domain modeling is concerned with the structure of the domain, like items, knowledge components, etc. Whereas knowledge modeling is the modeling of current knowledge of learners with respect to a particular domain model. Learner modeling is a general term encompassing the previous two. Coming on to the tracing methods, the first question that arises is, what is knowledge tracing? As described by Sapanzi, knowledge tracing is a family of machine learning sequence models that use these data to identify the likelihood of future learning performance. When we move into the depth of data representation for knowledge tracing, it can be represented as learning task. As we know, AI approaches are used for modeling sequential data, which implies that the data instances are not anymore independent and they hold a temporary pattern. This temporary pattern in knowledge tracing is the dependency between learners' time engagement within and between learners' resources. Domain knowledge dependence refers to the amount of human involvement necessary to tailor the algorithm to the learning task. Probabilistic sequence models like the hidden Markov model and dynamic Bayesian models are generative models called probabilistic sequence models. These are generally called as statistical learning models that incorporate assumptions related to the data generation process by modeling conditional dependencies between random variables. Deep recurrent neural networks are the methods that have been recently employed to the knowledge tracing task to solve the binary, highly structured and memoryless representation of the hidden knowledge state. The dynamic models of knowledge tracing that I am considering for this study are standard Bayesian knowledge tracing, individualized Bayesian knowledge tracing, dynamic Bayesian networks, deep knowledge tracing or the deep recurrent neural networks, memory augmented neural networks or dynamic key value memory network. Standard Bayesian knowledge tracing is one of the most popular user modeling method extensively used in the area of intelligent tutoring systems. This methodology assumes there are two states for each learner, that is, a known state or an unknown state for a given skill, and also with a certain probability of being in each. In this methodology, skill-specific discrete states are observed. Whereas individualized Bayesian knowledge tracing is the model developed by splitting the Bayesian knowledge tracing parameters into two components, that is, skill-specific and the student-specific, and by combining them by summing their logit function. By using the sigmoid function, these values are transformed to a probabilistic range. Over here, we can notice student-specific states on learning rates are observed. On contrast to the previous models, at each time step in dynamic Bayesian network, a learner receives a quiz-like assessment that contains problem steps or exercises that belong to different skills. We notice that the Bayesian network is repeating itself at each time step with additional edges connecting the knowledge state on a skill. The deep knowledge tracing model, rather than constructing a separate model for each skill, it joins all skills together to form a model. There are three layers in this model, namely input layer, hidden layer, and output layer. Deep knowledge tracing is a kind of recurring neural networks that takes the complete sequence of exercise performance space as input, and the hidden layer has fully recurrent connection that serves to retain relevant aspects of the input history, which are directly useful for predicting future performance. Dynamic key value memory network traces the knowledge of the student by reading and writing to the value matrix using the correlation weight, which is computed by taking the softmax activation of the inner product of the input exercise and the key matrix. Moving on to the methodology section, here the first thing I would like to discuss is the research questions. The major focal point of this research is to have a meta-analysis of various dynamic tracing methods in adaptive learning. Hence, the questions fall in this research are like, what are the various dynamic tracing methods? What are the parameters that are useful for the effectiveness analysis section? Which methods are more efficient? Various searches have been made to get the right papers and articles. The terminology used to search are adaptive learning methodologies, tracing methods, Bayesian networks, Bayesian tracing, deep learning, etc. After the results, the papers are selected or sorted based on the dynamic tracing methods and their methodologies used. The initial basic code study has been performed and the project follows the methodology like parameter fitting. The comparisons will be done between different tracing methods using various parameters. After getting all the required data along with the parameters, the main part of the project comes into picture, that is the analysis. A complete study of the characteristics based on the required parameters will be performed, and finally the results as well as the conclusions are drawn based on the same. As supporting docs, I have attached the tracing methodologies chosen and their basic info along with the literature survey in the Canvas. Thank you.